So in this clip, I'm attempting to show you how to use a trace table to test an algorithm to see whether it works. So here I have a little program written in Python, and I want to know if it works or not. The purpose of the algorithm is to take a binary value in string form. So here's my binary string 1010, and I want to see if it converts it correctly into its denary value. So if this works, I should get 10. Now you might be wondering why I'd want to test this if I know the answer, but I would like the computer to carry this out for me. So I might use this subroutine for more complex calculations, or for somebody else to use, for example. So the way a computer program works is each line is carried out at a time or executed. So I've got a piece of cardboard which I'm going to move through the algorithm just to show which line is being carried out. And what we do is we update our table with any data that changes. So let's give this a go. The first line is the definition of the name of the subroutine. It's called unsigned because this will only work with positive numbers, not signed numbers. And the input is binary, and that has been given. So I've decided I'm going to test it with 1010. Moving on. The first line of the code says decimal is 0. So it's an assignment statement. Variable decimal has been assigned the integer value 0, so I'm going to write that down. And if that changes again, I would just write it in the next row. I then have another assignment statement which says place value is 2 to the power of the length of binary minus 1. So like in maths, if you have brackets, you work from the inside out. So the first thing I need to solve is this one, the length of binary, which is 1, 2, 3, 4. So I'll just remember that. And then working out, it says take 1 off that. So 4 minus 1 is 3. And then finally I get 2 to the power of 3. So place value 2 times 2 times 2 is 8. I then get probably the most complex line of code in this. So length of binary we already know is 4. Range gives us a kind of a list. It's called a tuple, but let's not go into the detail of that so much. It gives us a list from 0 up until the one before the number that we've just put in here. So a little bit awkward, a little bit difficult to understand, however that's what happens. And this is a definite iteration, so it means it's going to repeat the indented code 4 times, and I is going to be each of these values. So we'll move on. So the first value of I is this one, is 0, so we're here now. And it says if binary I is 1. So I'm going to write out the binary string again, which is 1, 0, 1, 0. And this I with the square brackets refers to the index or position within there. So this is position 0, this is position 1, position 2, and position 3. So binary I refers to this string, but the ith position, which is 0. So it's a 1. So this selection statement here, if that character, which is 1, should have written that down, is equal to 1, then I need to do this. Decimal changes to itself plus the place value. So decimal is currently 0. We add on 8. So my decimal has now changed to 8. And now I'm up to this line. Place value becomes place value divided by 2. So it was 8 and now it becomes 4. And I'm not doing this return yet because this return is the indentation is back to normal. It's just part of the subroutine but not part of the iteration. So I need to return to the top, and I is now assigned the next value along the list. So we've done that one. I is this one. And it says if binary I is 1. So here's our binary string. There's the index. Binary I is 0. So I don't actually need to carry out this instruction because that's indented. But this next instruction I do need to carry out because it's not part of this selection statement. So I need to take the place value and it's going to become itself 4 divided by 2, which is 2. Okay, again I'm back here but I haven't finished the definite iteration yet. So back up to the top, and the next value of I is the one next along the list, which is 2. If binary I is 1, so this is I, that's best if I write it out like that. So we've done that one, So I'm in position 2, which is 1. And this statement is true. So this position of binary is 1, so I need to add my place value to the decimal. So decimal was 8, and I've got to take it and add 2 to it. So decimal is going to be 10. Okay, once again, I've reached this line, but I can't do that yet because I haven't finished the iteration. I'm now done with number 2, and I'm up to number 3, which is the final one, final value of I. If binary I is 1, here's I look down to here and see that it is 0. So I do not carry out this, because I only carry out this operation if this selection statement was true. But I do carry out this one because I'm back to the regular indentation for this iteration. So place value becomes place value divided by 2. And now because I have finished my definite iteration, I've been through all of these, then I move on to the next line and I return the string of decimal. So the return value would be that, which is what I expected. So my trace table works, or my algorithm works, being proved by a trace table for this input. What I'd probably want to do is test it for another couple more of inputs before I can definitively prove that it works.